All right, so what we're going to discuss in this video is a new way to measure the angles of a triangle or inside of a circle or in any situation where we've got angles. And it's called radian measure. And what we're going to do is walk through why it is that radians are called radians. And it goes back to the idea that any circle has a radius, right? So what I'm going to draw here is I'm going to draw in that radius. So from the center to the outside of this circle, that would be considered the radius of the circle, and I'll label it R. So now I'm going to picture happening is, let's say I take that radius R and I peel it off the page. So I take the radius off of the page and I'm holding it in my hand, all right? But it's the same length. There it is, the string that represents the radius R. Now what I'm going to do is I'm going to start placing that radius R on the circumference of the circle. So remember, that radius came from here. It is the radius of this circle. If I lay that radius down on the circumference of the circle, it'll take up a certain distance, and it'll take up a certain portion of the circumference of the circle. And so the question then becomes, how many of these radii do I need to make a full circle? Or how many R will equal the circumference? So I'm just going to start laying them down. It looks like I would need at least one more, all right, and maybe that would get me to about here. And again, I'm estimating, but I have a pretty good idea of what's going to end up happening here. So what you can do is you can pause the video and estimate, or if you want to, I mean, you could do this with a real circle and measure the actual radius and see how many of these radii will fit along the edge of the circle. So I'm just going to finish our picture here and see what it ends up looking like. All right, so I've just drawn a few more of these radii around the circumference of the circle. So this is one radius here. Here's another radius. There's a third, a fourth, a fifth, and a sixth. And you'll notice I'm not quite all the way around this circle yet. So I needed 6 radii to get this far, and I'm gonna need more. So I'm gonna need at least one more radius here. And that's gonna go more than one full circle. So 6 plus a little bit extra. And I will tell you that that number of exactly how many radii I need is 6.283185307 radii. That's how many equal the circle. And now in case you're wondering if it matters how big the circle is, it really doesn't. I could make a much smaller circle. Right here, let's say, that's a smaller circle. But because I have a smaller circle, I'm now also going to have a smaller radius. So this is my radius. And again, if I lay that down along the edge, it's going to take 6.283185307 radii to get there. And that number doesn't end. It's irrational. It's a non-repeating decimal. So what I can say is, instead of saying that a full rotation around the circle is 360 degrees, I could say that a full rotation around the circle is 6.283185307 radii. It's just a different way to measure how far we've traveled around the circle. All right, so if I want to say that I've only gone 1 radius, that would put me here, which we could figure out how many degrees that is if we wanted to. 2 radii would put me here, and I could figure out how many degrees that is, and 3 radii, and 4, and so on. But this is kind of an annoying number to use. So we end up coming up with a Greek letter that we'll use to represent a portion of that 6.283185307. And it's a number that you should be pretty familiar with. What I want you to do is to figure out, if this is a full circle, well then how far is a half circle? Right, so how many radii is it for me to go from where we're used to starting our angles to halfway around the circle, which I know to be 180 degrees, but I don't want to represent it in degrees anymore. I want to represent it in radii. So if 6.28 is a full circle, and I divide this by 2, then that'll tell me how many radii exactly it is I need to go halfway around the circle. And that comes out to be 3.141592654 radii. and that's a number that we're all familiar with. That's pi. So that's where pi comes from, is what we've decided is instead of saying that it takes 3.141592654 radii to go halfway around the circle, we say it takes pi radii to go halfway around the circle, or pi radians. So this new measurement that we're going to be using is called radian measure. And all it is figuring out how many radii we would need to get to that portion of the circle on its circumference. And you can take a look at the radius that we drew here. That was 1. This is our second radius. And this is the third radius. And you see that we did have a little bit extra. It was 3 and a little bit more. And that little bit more was the 0.14159 and so on amount of our original radius that we had to add there to go halfway around the circle. So we're going to start filling in the unit circle, and we're going to start converting between degrees and radians. But the big thing here is you understanding what radians means. And the big thing is when we convert between degrees and radians, it's pretty easy for us to say that half a circle is 180 degrees. But that is equivalent to saying pi radians. These are two different ways of saying the exact same thing, measuring half the distance around a circle. Another distance that we could measure would be 360 degrees. Instead of saying 360 degrees and using degrees to measure our angles, we could measure this in radians, and we could say 6.283185307, or we could put it in terms of pi and say that if halfway around the circle is pi radians, then a full circle is twice that. So in radians, 360 degrees is 2 pi radians. And we're going to use this notation in trig from now until the rest of your math lives. Radian measure is probably going to be the more important of the measurements, especially when we're doing trigonometry. All right? So tomorrow in class, we'll get into a little bit more detail about how to convert certain angles that aren't so easy into radians. But this should give you an idea of the concept behind radians. And I don't want you to think of it as just some arbitrary new way to measure angles. Think of it as just how many radii would you need to get around the circumference of the circle.